machine PowerPoint avec une seule machine?
Une seule machine. Ce sera plus simple. Il faut juste que j'ai cherché mon adaptateur avant que vous en ayez. J'avais imprimé, enfin, il faut que je retourne en bas dans tous les cas. Ok. Alors, workshop IF.
I'll take one from the outside where you all like working.
Yeah, let's do it like we're working. Oh, wait.
Yeah.
Yeah, we're very busy now. Instead of 12 hours.
Since it's work from here, it's controlling the camera anyway, so.
That's probably true. This was my work scene post. What's a work post?
No, it is. Yeah.
Sorry? Yeah, work post.
And a good one here.
Oh, I got the studios, right?
Yeah, this is too. They know you know that I'm here, so you can look at the pictures. I'll tell you what
I like that picture.
Great, awesome.
Thank you. Memories. Oh, can you take another one of my heritage?
Okay. But I cannot change your hair.
Okay.
Great.
Thank you, Ben.
Yeah. Shit, that's.
Better? Oh, never been seen.
That's almost a complete time. Het is een losse bommen.
Enchanté. Super, on s'était déjà rencontrés je pense, mais il y a peut-être 5 ou 6 ans quand j'étais au SnT. Sébastien, c'est quand on, je pense qu'on bossait sur CDR il me semble.
Oui,
CDR,
oui,
c'était un
avec
projet qu'il fallait rattraper, enfin c'était avec les handover, voilà, pour essayer de rattraper la mobilité. Vous faites partie du panel. Excellent, bah bienvenue, voilà. C'est très simple. Je vais aller chercher mes collègues et puis...
Et puis il y a notre ami de Proximus, et puis il y a
alors
l'administration.
notre ami de Proximus n'a pas voulu venir, il me semble. Voilà, bah, il n'était pas disponible en fait, donc voilà. Après l'administration de l'environnement, pareil, en fait, on a dit que c'est une entité publique, c'est pas mal de refus. En fait, il leur faut une approbation officielle, ils sont tous les sur le sujet. En fait, l'idée c'est que le panel est fait du SnT, de poste. Et après on interagit avec l'audience, on va voir sur le sur la manuel.
Personne de l'environnement ni de l'administration.
Mais ils sont là, en fait, ils sont là, l'audience. Je pense qu'il y a possibilité d'interagir aussi directement avec eux. C'est... Voilà. Mais voilà. Je reviens dans quelques minutes.
Sébastien, pour toi tout est bon?
Ma présentation vient juste d'être finie.
Pardon?
Je viens de finir ma présentation.
Ok, super.
Ouais, tout est bon, il faut juste aller chercher tout le monde.
Oui, voilà.
Bonjour.
Vos équipes? Faut juste faire attention avec le tour de cou. Creusez même de l'enlever, parce qu'après il risque de frotter, ça va faire. Le boîtier, vous pouvez le mettre dans la poche, le poser, c'est bon.
Voilà.
Parfait.
On a mis les groupes électrogènes en place aujourd'hui?
Je parle pas un petit peu de français. Mais
Ah, sorry.
oui.
Did you put some more powering in place?
Yes.
Okay. But what did
I don't know. They are only from the.
Ah,
Parce qu'en fait, ils savent pas, ils connaissent pas les circuits électriques de la salle. En fait, c'est pas.
il a dit que ça allait les déclencher.
Non, c'est pas repéré correctement, c'est bizarre. Donc, on a pas appris qu'il y avait 4 circuits différents.
Mais qui t'a les
Donc, on a
coupés?
bah, personne ne sait. C'est.
Classique. Personne qui a osé avouer.
Bah ouais, c'est possible, ouais. Non, mais c'est curieux, parce qu'en plus, on était en pleine session.
So it was difficult to recover everything.
Sorry.
It was difficult to recover the whole session. Restore the whole session yesterday.
Wait, was fine in the end. We lost, I think, 10 minutes.
On a un projet ensemble.
I hope. I was glad that it was starting again.
Yes,
And not like completely lost.
Ah, des voisins. Ah, mais...
They tell us there one laptop.
Okay, then I will ask Sebastian. So
Yeah.
probably he's,
Tell me, we can put another one if you want.
No,
And
okay.
tell me,
Yeah, with one
I
is
use your one for
okay.
all the
One is
presentation.
thanks.
Bonjour, je viens vous embêter 2 minutes.
Ah.
30 secondes.
Oui, ouais, allez-y.
On peut mettre ça dans la poche intérieure, ouais, s'il vous plaît.
Faut pas que je parte avec, c'est ça.
C'est mieux. Je dis, je vais encore en avoir besoin demain.
Et l'autre, de toute façon.
Ouais, moi je viens de vous voir. Par contre, si je peux vous demander, si c'est possible, ouais, parce que hier, en fait, quand on oublie le truc au-dessus, ça fait c'est pas très agréable pour les gens qui nous écoutent en stream, quoi. Ouais, c'est ça. Super, merci monsieur.
Asking some of the questions with Sebastian. Nice to meet you.
Your key.
So maybe take your one of your papers.
Yeah, please.
Ils n'ont pas de son sur les PowerPoint, sur la présentation.
Pas à ma connaissance, non.
Ok.
On peut laisser l'ordi là?
Ouais, vous pouvez l'avoir là. Je mets le clicker dessus, il y a des gens du bout de la table qui ont besoin.
Ouais, c'est peut-être plus simple pour le clicker.
Bon, je clique. Vous avez un USB, oui, un USB sur le.
Ouais. Bon, ça sera peut-être plus simple que j'aurais fait avec les USB même.
Ah ouais.
Sachant qu'il y a peu de contact là-dessus. Les Linux, il peut pas.
C'est les Macs, c'est génial.
Ah, c'est magnifique les Mac. The keyboard cannot be identified. Ok.
Le keyboard, il prend la remote comme un keyboard.
D'accord, ok.
On va faire un petit test.
Ouais. Alors, je fais des présentations là. Tac. Je vais fermer Teams. Normalement, je suis en mirroring. Ah oui, mais non.
Là, on a le deuxième micro.
Ok. Connecting to mode. Tac.
Bonjour, c'est Ryan.
Hey, bonjour. Good afternoon. So this is our first speaker. Welcome.
How does this work? I don't see where I'm supposed to stand.
Well, so basically all the speakers are here. We are like 6, if I'm not mistaken.
So
And
I will be able to see my screen and my notes.
maybe, yeah. I mean, I mean, there is only one computer today.
Okay.
But you can give me your PowerPoint and you will see your notes here. Right?
Okay,
If
then
you
I
want.
will send it to you quickly.
Okay.
Because
Or
they said
if you have an
bring
USB
your own
key.
computer, I thought I will see
We have time. We have 8 minutes. Totally fine. Alors, comment lancer un PowerPoint? Hop. Yeah, please join the panel, I mean. Ok, est-ce que ça marche? Ok, c'est l'unique slide que j'ai, mais j'imagine que ça fonctionne, c'est bon. Ouais. Ok. Yeah, please, I will be here, that's fine. that I'm very close to.
C'est votre avis, je crois. Alors, attendez-vous pas la mienne, je suis le mien.
I'm just connecting to the VPN so I can send it to you. Teams. Is that okay? Yeah, I'm sorry, I'm not very pushing the topic, therefore my notes are very useful.
You have 7 minutes.
Okay, thanks.
Il reste du coup un cravate et un main. Alors je sais pas si tu préférais utiliser le main ou plutôt le cravate.
Ça me dérange pas.
Quel, je l'ai déjà équipé, mais après si if you want to change, you can. If you prefer, I have a mic.
For the questions, I think it would be better because then we cannot speak at the same time. One has the mic and then we pass for the other. But for
No.
the presentation, it will be it's okay.
Yeah.
So you also have a 20 minutes presentation. Okay.
Ah, okay, yeah.
That's why for the panel actually they only need one of the mic. That's essential.
But the panel they have this.
Yeah. I have only 5 on. I have only 5 like this, 5 mic type.
No, this is fine. I will use it. Hello. Ion, can you hear me? Yeah.
Sure. Yeah.
Yeah, that's fine.
Or maybe.
Do you prefer the mic?
I think it's better for you to have a mic because with your jacket, the mic will be don't.
Because this is how to say this is recorded.
Yeah.
It's recording and we have
Okay.
stream live. And you have a jacket or no?
No,
No.
like this?
So I think
Are you
it's-
convenient with the mic?
Okay.
Yeah.
Everything will be fine.
This one instead of this one.
Yeah, sure.
Okay. Because then it's a stake.
Not very hard. We speak about 5G. It's
You've been presenting stuff over the computer.
It's easy. You just took the mic.
Okay.
You put.
So I will be standing, I assume.
Yeah,
As you want,
sure.
you can see it.
Can you check? I just sent you the PowerPoint and to see if I will be able to have the.
C'est bon? Okay. Well, good afternoon, everyone. Thank you very much for being here. Well, thank you to our physical audience. Thank you as well to our online audience. I can see that 20 people are currently connected. So, well, welcome to all of you. Please do not hesitate to ask questions in the chat. I mean, this is an interactive workshop, so I guess this is the least that we can do. So today we are going to speak about the exposure on electromagnetic fields and as well interference management. This is a big topic in Luxembourg, this is a big topic in Europe, and we basically initiated this workshop initially with SnT, and we thought it was quite important to actually discuss these topics. So today we have 5 different sessions, actually 4 different sessions if you include the introduction. Of course, this is quite a small session. So the first presentation will be made by List. Basically, it will be an introduction on the regulatory framework, so that you all know what are we talking about, what are the limits, what are the parameters, and so on. And then we will have a presentation of about 2 projects. So one project covered by List and one project covered by SnT. So these are 2 research projects about exposure and interference management. And then we will finish with a panel discussion. So basically for the panel discussion we have 3 members here from List, from SnT, and from Post. Thank you for being here. And well, this is it. So I would suggest to start maybe with a small tour de table so that everyone can introduce himself. I would suggest to start.
Hello, I'm Thierry Contrasuk from Post Luxembourg. So I'm working in the radio planning department, so mainly dealing with the key performance indicator, the planning tool, and the engineering databases, and also some aspect of the EMF.
Great. My name is Jamal Kadraoui from List, head of one of the research unit from the IT department of List. I coordinate teams working on 3 main topics. One is on the optimization, process optimization and transformation. The second one is all what is related to distributed networks. And the third one is about trusted data security related topics.
So I'm Simeon Kardinotas. I'm a professor at the University of Luxembourg. I'm the head of the SICOM group. We are about 70 researchers working on different areas of telecommunications and networking. And we have a particular also focus on space and satellite communications, given the political support that this is receiving in the country.
Thanks, Simeon. My name is Jorge Querol. I'm research scientist in the SICOM group of SnT. I'm coordinating some of the 5G-related activities in the group. And today I will be presenting you this IRANATA project related to 5G and electromagnetic exposure.
My name is Raya Ziga. I work at Luxembourg Institute of Science and Technology. Oh, sorry, I forgot the mic. So my name is Raya Ziga. I work at Luxembourg Institute of Science and Technology, more specifically in the Environmental Policies Group. Mostly I work with chemical regulations, but in the past year we were involved a bit with other regulations and a bit more about 5G legislation and so on.
And my name is Sébastien Faye. I also work for the Luxembourg Institute of Science and Technology as a researcher mainly involved in 5G, 6G activities
basically within Jamel's team. Okay, so well, I guess we can now start with you, basically. We'll just, well, inverse. Okay.
Yes, so as I already said, I need to remember to keep this in my hands. I will be giving a small background overview on the regulatory framework related to the electromagnetic fields. And to start with a short introduction, so in order to keep up with the new wave of digital transformation observed across the industry, there has been a need for a new and innovative network to improve the core wireless technologies. As you know, then, to satisfy all these requirements, the 5G was developed as the next generation of wireless access technology. And to give a mini overview on the 5G, and as a non-expert, maybe it will be funny to hear it, the 5G compatible networks are structured around 3 development axes: the speed, the latency, which is response time, and the density. So in fact, the requirement for 5G anticipates speed up to 10 times higher than those for 4G, a latency on the order of 1 millisecond, which is 10 times better than 4G, but then also an increased number of connected objects, which means a higher density. And then on the European Union level, it has been identified some pioneer frequency bands for 5G, which are presented in the pink in the scheme. I hope you're all able to see it. We can see a band of 700 megahertz, and then a band in the 3.6 gigahertz and a 26 gigahertz band. But together with the introduction of the mobile communication technology, there has been an increased public concern about the potential health risks associated with the use of mobile phones in the living near base stations. So for all radio frequencies, international maximum levels were designed to avoid any adverse health effects. And with public concerns, some authorities have even introduced precautionary exposure limits, which vary considerably between the regions. These measures are based on the precautionary principle and should be proportional to the chosen level of protection, but with keeping in mind that a zero risk cannot be achieved. So during this presentation, we should provide you with a general overview of the different electromagnetic field exposure levels, which are defined in the international as well as in the European recommendations, but then also compare those levels with the levels considered in the national law for Luxembourg. But to start with, I will be introducing the concept of precautionary principle, which is quite important for the next slides. So this precautionary principle is detailed in a European treaty and aims at ensuring a higher level of environmental protection through preventative decision-taking in case of risks. This principle enables decision makers to adopt precautionary measures when scientific evidence about an environmental or human health hazard is uncertain and the stakes are high. These measures taken through the precautionary principle should always be proportioned to a chosen level of protection and should never be discriminatory. So now we will start with the exposure level limitations as presented in the international level. So in 1998, an International Commission for Non-Ionizing Radiation Protection, shortly IGNIRP, has published guidelines for limiting the exposure to time-varying electric, magnetic, and electromagnetic fields with frequencies up to 300 gigahertz. These guidelines represent exposure levels based on scientific studies which apply to occupational and general public exposure. with the aim to provide protection against known adverse health effects. And in order to apply these restrictions based on the assessment of possible health effects of electromagnetic fields, the ICNIRP has developed two types of restrictions, what we call basic restrictions and reference level for limiting exposure. To start with the basic restrictions, these are internal measures of exposure in terms of biologically effective quantities. They are based directly on established health effects and biological consideration. The ICNIRP basic restrictions of general public exposure are presented in the following table, as you can see. These physical quantity used to specify these restrictions are current density, specific energy absorption rate, power density. These are quantities that could be very difficult to measure. So as a side note here, I only presented the numbers related to general public exposure, but in the guidelines from ICNIRP, they have been treating both general public and occupational exposure, but the values usually for the general public exposure are smaller than for occupational exposure, just to prevent indirect effects on individuals. Then on a second note, then we have reference levels for limiting exposure, and these are measures related to the internal measures of exposure, aka the basic restrictions described in the previous slide. They are actually expressed in terms of directly measurable quantities of external exposure. So these are defined as levels which provided for practical exposure assessment purposes to determine whether basic restrictions are likely to be exceeded. In fact, the reference levels are physical quantities that are stricter than the basic restrictions to avoid potential risks, but they are also considered easier to measure and to assess. So to summarize, basic restrictions are closely related to biological mechanisms, while reference levels are easier to evaluate and are used to ensure compliance with basic restrictions on exposure. Then we can say that if the reference levels are exceeded, basic restrictions are not necessarily exceeded. Now, on the European level, in 1999, so 1 year later, the Council of European Union has published recommendations including frequency-dependent reference levels for general public exposure, which are considered as limit values. The Council recommends that, with the aim to provide a higher level of protection, the Member States should adopt a framework of basic restrictions and reference levels that are identical in definition as in the ICNIRP guidelines. This means that for general public exposure, the limit values defined in the 1999 EU recommendations are identical to the ICNIRP values presented previously. Consequently, many European countries implemented the EU Council recommendations and hence the ICNIRP guidelines in their legislations. Just note that the reference levels for general public exposure for from the European recommendations are values intended to be averaged both over space and over a period of 6 minutes, which is also in accordance with the ICNIRP guidelines. Now, as said, many European countries implemented the EU recommendations and hence the ICNIRP guidelines for general public exposure in their legislations. But according to the recommendations, Member States should stay informed of scientific and technological progress in the field of non-ionizing radiation protection, especially with taking into account the precautionary aspect. Taking all this into consideration, the countries within the EU handle the recommendation in different ways. According to this representative scheme, we can observe 3 groups. For Group 1, which is in purple, the recommendations are implemented in national legislations. The reference values then are defined in the European Union are obligatory. We have also a second group, which is in pink here, where the recommendations of the Council of the European Union are not implemented. There are either higher limits in comparison to the recommendations by the European Union, or maybe there are no regulations at all. But then we have a third group represented in yellow, where national regulations are stricter than the EU Council recommendation. They rely actually on the precautionary principle, or they applied stricter requirement based on the general public requirements or needs. But this scheme should not be taken as a reference, as for the case of Luxembourg, we see it in purple, meaning in the group 1, but in reality, Luxembourg could be considered as group 3, hence in yellow, and I will explain this in the next slide. So the exposure levels in Luxembourg are actually based on the EU recommendations and the ICNIRP guidelines. So the limits of cumulated exposure levels in Luxembourg, which I repeat are based on the European recommendations, vary between 61 and 38 volt per meter, depending on the frequency. In this table, we see that for frequencies of 700 megahertz or 3.6 gigahertz, which are assigned for 5G technologies or network, the maximum value of the cumulated electric fields are respectively 38 and 61 volt per meter. However, with respect to risk reduction, few measures were taken in the application of the precautionary principle that was explained earlier. So in order to limit the risks, reduced exposure levels generated by radio communication-based stations have been defined. On that regard, Luxembourg imposes an additional requirement as a precautionary measure with the aim to reduce the risk of exposure to a tolerable level. The tolerable level is defined by setting a limit value as within the framework of special permit for the radio technical sites for electromagnetic wave transmitters. This derives among others from a law commonly referred to as Loi Komodo. These permits contain installation and operation conditions deemed to ensure compliance with the essential requirements of the before-mentioned Loi Komodo. A permit is therefore only delivered after the authorization request has been thoroughly examined, which includes field strength simulations, proving that the compliance is compliant with within the regulatory limits. So in the framework of this permit, classified establishment authorization have set a maximum value for the contribution of each radiating element from the mobile phone base station, significantly lower than the values in the EU recommendations. So in Luxembourg, these lower human exposure levels in the bandwidth used for mobile communications consist in a maximum contribution to the general electric field of 3 volt per meter as a maximum value per radiating element, which is applied in the vicinity of lieu de séjour, which is where humans stay the longest. I have a problem to go lower here. Do you know how can I just? Yeah, thank you. So again, the contribution to the cumulated level is in fact set to 3 volt per meter per radiating element, which corresponds to 7% of the cumulated level of European reference, for example, for the frequency of 900 megahertz. This means that after receiving a permission, the operator must install his antenna in such a way as to guarantee a maximum electric field strength of 3 volt per meter per radiating element in any place where people may be present. With this limitation, even with a larger number of electromagnetic wave emitters installed on a site, the resultant of the accumulated fields at a given emission point, even in the vicinity of radioelectric sites, should remain significantly below the reference level of the European recommendations. For example, For 6 transmitters emitting in a maximum authorized power mode in the same direction with the same antenna pattern with equal signal characteristics, the resultant calculated as equal to 7.3 volt per meter, which is way lower than the limits. In this slide, I will shortly indicate some inconveniences related to stricter electromagnetic field exposure limits. For example, it could lead to an incomplete deployment of the spectrum and hence restrict the technology promised with the 5G, for example. But then, on the other hand, the benefits behind applying stricter exposure limits should not be ignored. The most obvious benefit is the reduction of the risk on the human health and the environment. In fact, when applying stricter exposure limits, one should observe smaller field intensity near the antenna. Thus the likelihood of effects on humans and the environment might be lower. So setting operation conditions in the individual permits for antenna sites, fixing the contribution to one radiating element to be below 3 volt per meter will eventually help reaching a lower general exposure level in the vicinity of these antenna sites. This action will also allow the same treatment for every operator involved. So the main advantage of a device-specific limitation compared to an accumulated value is mainly to prevent competing behavior in different frequency, technology, and operators. So I think I'm slightly over time, but I'm almost done. To conclude, Luxembourg does not consider cumulative limit values. Instead, the limitation is imposed on one radiating element for precautionary measures, but then with the aim to be a leading country with a 5G network deployment, Luxembourg is multiplying its effort to continuously revise its electromagnetic field measuring method for a more efficient exposure level assessment. In fact, with the implementation of the 5G technologies, many efforts are focused on adapting the electromagnetic field measuring procedure to increase their efficiency and to avoid any overestimations. And with that, it will avoid any incorrect exposure assessment in the case of 5G particularly. So this could be the work for our colleagues in research and development, and that will play a huge role on the future of these limitations maybe. And on this note, I come to the end of my presentation. Thank you very much for your attention.
Okay, thank you very much. So let's just take a few seconds, maybe if the audience has, do you have any kind of question to ask following this presentation? Maybe not. I'm just checking on the online platform. Yeah, in the meantime. So no questions so far. Good. So now we move to the second speaker to present one of the research projects that have been funded by the SMC on this specific topic. Let me just open the presentation. Okay, this one.
This one, yeah.
Okay, floor is yours.
Okay, thanks a lot, Sebastian. Okay, so I'm going to talk to you about the IRANATA project. IRANATA stands for Interference and Radiation in Network Planning and 5G Active Antenna Systems. And the focus will be, in this latest part, the measurement or characterization of the new active antenna system that is a new feature on the deployment of 5G. So we'll talk a bit about the project, an overview of the project, then about the measurement methodology we are proposing, and then I will show you a bit what is the experimentation equipment we have in-house. First of all, a bit more on who we are. So we are SnT, the Interdisciplinary Center for Security, Reliability and Trust. We are affiliated to the University of Luxembourg. We are a bit more than 360 people from 66 nationalities. This is very common in Luxembourg. And our statistics shows that 36% of people that it's coming out, formed out from SnT is contributing to the labor force of the country. We are very active in projects and in innovation. We have up to 56 partners, companies that are running projects with us. Over the years, we accumulated more than 180 millions in competitive funding, and we created 5 spin-off with different technologies. In this particular project, there are 3 research groups involved in Iranata. The first one is SIGCOM, Signal Processing and Communications, headed by Professors Björn Ottersten and Simon Hadjenotas here with us in the panel. The second group is Automation and Robotics, headed by Professor Holger Boss, and the third group is Space Robotics, headed by Professor Miguel Mendes Olivares. Talking about the Iranata project, us, SnT University of Luxembourg, are the coordinators of the project, but with us we have 2 partners, 2 national network operators, Proximus and Post. And this is a project funded by the government, by the SMC. And the scope of the timeline of the project is 2 years. It was kicked off at the beginning of the year, and so far we had a milestone review to check the configuration of and the proposal for the project. So about which are the challenges and objectives of Iranata. As I was mentioning at the beginning, the main challenge is how to define a methodology to cope with the new challenges of the 5G active antenna systems, and also to do this taking into account or also performing electromagnetic emission measurements. And in particular, we have different objectives, as I was saying, the characterization of the active antenna systems in terms of out-of-band emission, intercell interference. These are new challenges posed by 5G. Another one is getting network coverage map, but in this case in 3D. So the active antenna systems are able to synthesize beams in the 3D, in the 3 dimensions. So we also need to validate and to estimate this coverage map in the 3 dimensions. And of course, as I was mentioning, very important, electromagnetic emissions. Of course, we are aiming to disseminate results to the scientific community, but also to provide input to the private and the public stakeholders and entities in Luxembourg. We aim to propose new KPIs adjusted to the new challenges, and of course, improve the awareness of the general public about 5G. Latest slide about the introduction to the project itself. In this project, we are targeting, or we are aiming to generate impact in 5 different areas. The first one is economic, so how we can help the operators to optimize the network planning for the new 5G systems and develop these characterization methodologies. From the environmental point of view, how we can address the radiation concerns. From the government point of view, how we can accelerate the deployment of 5G in Luxembourg, and of course provide input to the regulatory bodies. On the social part, how we can improve the quality of experience of the users and also create awareness, as I was saying before. And the latest point is very important for SnT as well, is both the knowledge transfer toward the network operators, but also on the other way. So getting domain on the knowledge towards the IP of the university, and eventually spin off this methodology we are proposing in the project. Regarding the different proposals that we are considering for the new challenges, in terms of electromagnetic field strength measurements and also antenna pattern characterization, we have a first methodology, let's say, to being able to evaluate what is the peak radiation. So with the beamforming, we are adding the complexity that the radiation is depending on the spatial domain. So, of course, the first point is to characterize what is the maximum radiation on the bore side of the beamforming. So, to do so, we are in contact with the operators to define different ways of exclusivity access to the base station. And with that, what we want to achieve is, or to set, is a single user equipment that can receive the beamforming from the antenna. And then we'll be setting different kinds of electromagnetic field meters. And with this, we will be able to get the maximum peak radiation. Then, as a second step, of course, this will be dynamic. And this is why we're introducing the UAVs. So UAVs will be a tool for this project to be able to cope with the dynamicity of the active antenna systems. And for that, we can put on board different UEs and then make a scan. So with this scan, we can get two different kinds of measurements. One is the field of view of the active antenna systems, and how this characterized with elevation and azimuth. And also get measurements from the side lobes with an electromagnetic field meter on the ground. So once this beam is pointed towards the 3D space, basically, how the radiation is affecting to the people on ground. This is one of the methodologies we are proposing. And then next step will be getting full characterization of the antenna pattern. And to do so, now we'll keep the user equipment fixed. So the beamforming is directed towards the user equipment. And we are proposing to have a 3D scan with another equipment that basically we want to measure then power or direct electromagnetic field. And we are going to perform this 3D scanning to get also first of all, estimation of the 3D antenna pattern. And with this, we can derive, in the end, beamwidth and directivity. So together with our colleagues from the aerial robotics groups and the spacer group, we are trying to understand what is the most efficient way to do these measurements with UAV. So what the challenge itself is to measure the signal strength with different waypoints so that the UAV can follow these different waypoints. And we are trying to define this in an area that is with a constant distance to the base station. Once we define these sort of hemisphere waypoints, our colleagues are looking how they can optimize the route along these waypoints so that we can minimize basically the scanning time according to the autonomy of the battery or the battery cycle of the UAV. This is also one of the big challenges. Of course, this is still under definition. This distance between the base station and on the waypoints have different trade-off, like what is the spatial resolution we are targeting versus what is the time that these measurements will be taking. So this is part of the research challenges on the project. One more of the KPIs that I was mentioning before was to determine the 3D network coverage, not just on the ground, but also with respect to the elevation, and also intercell interference measurements given that the user equipments are no longer attached to the ground, they can be flying. So for this, the equipment we are trying to use is a signal analyzer. I will show you different kinds of equipments that we are considering. But basically the idea is that with this signal analyzer, we are going to perform also a scanning in the region, in the vicinity of the base station at different altitude heights, so then we can get both network coverage maps and also intercell interference maps. The way we are trying to address this is not just we are scanning the area randomly, but we are trying to address it also in a smarter way for the UAV. So we are designing also a UAV path planning for that. And the idea is using sort of contour maps. But in this case, instead of altitude, what we are trying to use, or what we will be using as a constant contour variable, let's say, is the signal strength. So we will fly around the area. And of course, closer to the base station, there will be circular routes. But once we get far from the base station, then the environment will start playing. Buildings, trees, other elements there will be modifying these routes. And in the end, we will try to get these contour maps according to the signal strength. And basically, we are doing so because it's a way to also minimize the time of scanning and maximizing the autonomy of the UAVs. That concludes the part related to the measurement methodology. But before starting the experimentation equipment, maybe we should mention that at the beginning we are trying to do or to address these measurements on the 3.5 GHz band, which is the one that is posing more challenges in terms of the active antenna systems. Then starting showing a bit about the experimentation equipment we have in the IRANATA project. First of all, we have a different set of electromagnetic field measurement equipment. And we started with showing you this one, which is, in any case, any kind of equipment we are using for this measurement has to be calibrated and validated. And the first one we purchased is this equipment, this wave control SnP2. The characteristics of this equipment is that it's scanning all the bands at the same time. So it ensures you that you are getting the full radiation from all the different bands on the base station. And in particular, the probe we have available is capable of measuring between 0 and 40 gigahertz. It allows us to get 3D components for both electric field and power density. It has already predefined some of the standard complying parameters, like the time of integration according to the international regulation standards that our colleague was commenting before. And of course, it's battery powered, so it allows us to do measurements in the field. As I was saying, this is all spectrum, but then we are looking at other equipment that in this case is frequency selective to do more specific measurements. This is some equipment that it's from Rodensvars, and they are allowing us to test this equipment and performing different validation within the project in collaboration with them. So there are two kinds of equipment. The first one is frequency selective. So basically, it's we are able to tune the specific band, in our case the 3.5 gigahertz, and then it aggregates all the emissions in the given band. This is a first level of capability. And then we can go to the next level of capability, that is code selective EMF measurements, which is basically, instead of taking into account all the signal, all the 5G waveform, we are only having a look specific broadcast pilots, because this will be constant over time, and this will give us a better estimation of the maximum radiation emitted by the base station. As I was saying, we are right now at the process of exploring different alternatives to get these measurements. As I was mentioning before, we want to mount on the drone 5G capable user equipment, and so far we are exploring this 5G HUD for a Raspberry Pi. So our colleagues from the robotics group, they are always concerned about what is going to be the weight, the power consumption of the equipment that we are going to install in the UAVs. And we found this as a good trade-off solution, because basically it's small size and also it's very efficient. And it allows us to get 5G connectivity in the 3.5 gigahertz band, and basically it's able to get us also some of the important measurements like the received signal strength of or SNR for the measurements. Moving forward, going through the other KPIs, the network coverage and interference measurements, we are evaluating two different tools. The first one is also from our colleagues from Rodan Svars, the QualiPox solutions. So this is, as I was commenting before, a code-based, code-selective solution that is able to get both coverage measurements and interference measurements off the shelf. But at the same time, there are other challenges that are mainly based on the synchronization aspects and other challenges that are not, or we are investigating, that we can address with open source solution, which is basically, it's called, Open Air Interface. It's a full stack that is back up with an open source community that basically there are different companies and institutions that are working on this. We are using this also for different developments in other projects. And for this one is a way to complement the solutions that are in the market for specific measurements, like for instance, algorithm based on multiple antennas, MIMO, or mitigation strategies that we are investigating also for the project. I will finish my talk pointing to two other activities that are running in the conference that are related to IRANATA. The first one is a workshop that will be given from our colleagues from the other research groups about 5G and UAVs. They will be talking about the challenges of the experimentation of 5G with UAVs, and also about the current UAV regulations that are also posing a lot of challenges for the IRANATA project. Another activity, or basically another way to go deeper into the equipment we have, it's at our booth. So basically we had there a setup related to a project that is called SAFER, that is it's dealing with the demonstration of safe electromagnetic radiation in 5G active antenna systems. And basically this is a very simple setup comparing two kinds of antenna according to the directivity, and how more directive antennas can help to reduce the overall radiation from 5G systems. So I will end up with this slide. This is all the team, all the people that is working on the IRANATA project, and I will be taking questions from the audience if we have time for that.
Yeah. Yes, please. Can you please take the mic?
Hi, Ion Turcanu, Luxembourg Institute of Science and Technology. Thank you for the presentation. Very interesting. I have a question regarding how these results that you are going to obtain, how generalizable they are. Let me just explain. So the idea is that you are going to do these measurements in collaboration with specific around some base stations that are. This is just some equipment from network operators here in Luxembourg, right? So how dependent are these results on the specific base station, on the specific environment, and whether they can be generalized to other base stations in other kind of environments?
Thanks for the question. So our goal is to perform these measurements in a new base station site that will be located in our building here in the campus, Kirchberg campus. And this is why we are working with our colleagues from Proximus and Post to get their equipment installed there. And then this will be, of course, also depending on the vendors. The operators, they are working with different vendors, but this is why we have different entities that we are collaborating. So we can do same kind of measurements over different equipment and then compare the results. And I'm not sure if generalize that, but at least we will have measurements from different kind of equipment, and we can compare among them.
Maybe
Sorry, just follow-up question. Will these results then be made publicly available to the research community?
So the idea is that the results will be the ones that are not concerning any privacy policy. Of course, this will be disseminated.
Excellent. So we can all benefit from these results. Is there any other question in the audience? I can see that, well, there is no online question, basically. So if this is all good for you, maybe we can move to the next speaker, which is myself, basically. So maybe we can go back again here. So given the time, I would like to let at least 30 minutes for the panel. So, well, we'll just try to accelerate a bit, well, so that we can get an overview of this second project quite easily. Let me just launch the presentation. Okay, good. So the second project to be presented today is called 5G Emit. So let me go directly into the details. So this is basically also a project that has been funded by the SMC under the framework of the first call for 5G projects 2 years ago. This is a project that will last 2 years and that well already started beginning of January this year. In this project, we are collaborating with Proximus, Luxembourg, and this is it. So we are leading this project basically. So let me just start with a few motivation slides. I think it's quite important to maybe introduce this context. Well, I think this is not a new information for most of you, right? But it's just to highlight a bit, you know, these topics. I mean, this is also why we are all organizing a workshop, I guess, today. So all these, I mean, are the let's say the 8 key challenges that have been identified by well, a community managed by IEEE, which is called the Future Network Community, quite popular among the scientific and standardization community. And basically for 5G, when it comes to 5G, to future wireless communication technologies, they have identified a total of 8, well, these 8 challenges. And when you see all the challenges, well, you can see satellite integration, energy conservation, sorry, and so on. But then you can see 2 challenges that are directly covered by this project, and well, I guess also by the project of SnT, which is about the regulatory compliance. I think this is what we are talking about today. This is why we need to perform measurements. This is why we need to revise a bit the way it is maybe calculated today. You know, it's a bit in between calculation and measurement always. When it comes to the regulatory framework, but this is a challenge clearly for 5G today. This will be a challenge for 6G tomorrow, and probably for the other generations. Then we have another challenge related to network management. Well, of course, the networks are becoming more and more complex. Now we are talking about service-based architectures, which are quite more complex to manage, to deploy. I guess well, our colleagues from Post, Proximus, and the other operators can probably give a few words on that. But this is definitely a challenge. And then, of course, we have an indirect challenge that is also covered by this project and also the other project from SnT, which is basically about the public resistance. So this is not from me, okay? This is directly extracted from the document from IEEE. But I mean, I think this is aligned with a few messages that have been discussed. Now, I think we have a responsibility as research entities to raise the awareness of the general public so that we can really explain, maybe communicate a bit more about 5G, the different applications that might be, let's say, deployed with 5G. So basically this project, 5G Emit, covers the 2 parts in green, so the network management part and the regulatory compliance part. This is one of the main motivation. And then, well, we'll spend a bit less time on this. But I think it's also another important message. This is this is a key justification, I think, behind the fact that research entities work on 5G, 6G, and so on. It's simply the fact that, well, technology is there. I mean, it's ready, right? We already have vendors, manufacturers that are here. I mean, the technology itself exists, let's say. But the fact is that it would still take a few years, to see this technology fully deployed and to reach all the capabilities of this technology. And for that, we have several factors that, of course, affect the deployment of this technology. So we have the regulatory factors. This is the first in this list. We have the community factors. So basically, all the perspectives affecting, let's say, the health, for instance, and what. Basically concerns the general public. And then we still have technology issues and standardization issues. So all these, the result of all this is that the deployment of 5G might still take, let's say, a few years. And then, of course, you have the business cases and so on that still need to be a bit, solved and then developed. So this is basically why I think we need research and innovation in that case. Because probably we need decision support systems, probably we need optimization to better deploy, to better optimize the way that the antennas, for instance, are located over a given territory, even if sometimes this might be a bit constrained. And then, as I was citing just before, awareness. So these are just a few messages. Now I will quickly present the project, 5 minutes. So basically, the motivation behind this project. The fact is that today, when, let's say a network operator wants to deploy a cellular antenna, be it 2G, 3G, 4G, 5G antenna, then of course there is a regulatory framework. I mean, it's not like you can do whatever you want in a given territory. And, this regulatory framework has, as my colleague explained, given limits, so you cannot exceed these limits when an antenna is deployed. But then there is behind the methodology. So the methodology actually that is currently in place, at least in Luxembourg, in Europe, in most of the countries, this is quite a complex methodology because you need calculation, you need to estimate if your installation will be compliant or not with the regulatory framework. And then when it's deployed, you need measurements. So all these need, of course, to be, quite compatible with 5G, I guess. With the 5G technology. The fact is that it's not always the case. So most of the methods that exist today, most of the calculation methods, the measurement methods that exist, all these methods are not necessarily compliant with the fact that 5G relies on active antenna systems. So what happened in that case is that the result of all that is an overestimate, basically, which might prevent the deployment of new 5G antennas in a given territory. So what we are doing in this project, 5G EMIT, is really to try to propose and validate an operational methodology for assessing the EMF exposure produced by 5G technologies. This is a project on which we are working, of course, in close relationship with network operators, but also with the regulators, and we are also looking into the standards. So the objective is really to try to facilitate, to support the deployment of this kind of technology in Luxembourg. We are also considering the regulations that exist in Europe. And, the objective would be to come with a concrete prototype at the end of the project, or in 1 year time, basically, that could be used then by the different stakeholders in this 5G ecosystem, at least in Luxembourg. This is, an actual software solution that will be provided at the end of the project. So not only scientific papers and so on. Now I will quickly pass over these slides. So this is just, these are just, let's say, the basics, saying that today, if you want to assess the exposure of a given cellular technology, you have obviously two methods. You have a measurement method. So as well, again, my colleagues presented, you can just go around the antenna and then try to measure what is the instantaneous, let's say, EMF level. You can use drones, you can use different methodologies. What we are interested about in this project, just focusing on this measurement part, is to, let's say, measure the variation of the EMF for a 5G antenna over a long period. Because we all know that, again, 5G antennas rely on an active methodology, right, on an active antenna system, let's say. So this means that basically the EMF exposure will change depending on the number of users, depending on the number of the overall behavior, let's say, of the environment around the antenna. So what we would like to do is to have a long-term methodology, a long-term measurement methodology, so that we can really try to correlate, let's say, the behavior of massive MIMO systems with, the actual EMF levels and then, let's say, the population around that. So this is the measurement methodology, and then, obviously you can also use calculation. You can also use different formulas that are well known by the scientific literature, and they are all about let's say, estimating for, by taking into account this and this parameter representative of the, let's say, the output power mainly of the antenna, what could be the maximum, let's say, EMF exposure. So we are also working on that, since, most of the calculations methods that exist today are not compatible necessarily with 5G. So, again, I can see the time, so we just speed up, so, these are basically just a few methods that, on which we reference from the literature. This is quite conventional, but still not necessarily compatible with 5G. So what I will present, because I really would like to go to the panel, then it's basically the outcome of this project. On this project specifically, we would like really to, let's say, combine, these two approaches, so the calculation and the measurement approach. So, I was talking at the beginning about a decision support system to be built in collaboration with network operators, regulators, and so on. So what we will do in this decision support system is to use a simulation approach. So this is basically what has been presented this morning. We will use a realistic model of Luxembourg, a 3D realistic model of Luxembourg, realistic 5G antenna patterns, and so on, and we'll combine that with real measurements coming from the reality, so that we have, let's say, a decision support system that is realistic and that can ease all these, let's say, EMF assessment process that usually takes quite a long time, and which is not, always optimal, let's say. So, I will just finish my presentation because I do not have, time remaining to go to the panel. Maybe if there is any question during the 2-3 remaining minutes, we can take them. So please do not hesitate. Be it for this presentation or for the presentations before, just moving to the panel, because then it will be an interactive session. Just do not hesitate. Any question? Good. Oh.
Maybe I have a question here.
Yes.
The outcome you talked about.
The mic, yes, please.
Yeah, thank you. The outcome you talked about, the software, will that be publicly available, or will that be limited to the professional usage?
Well, this is something that still needs to be decided, but I can easily imagine a public part, okay, with publicly available data. This is, like SnT, we also would like to share, any kind of use of data that might be useful in the context of the project. And then I guess we will have a private part depending on, your interest, if you are a regulator, if you are a network operator. But this still needs to be decided, and I guess we will not decide alone. This is a discussion to be organized with the relevant stakeholders. Yeah. Okay. Thank you. I'm just checking if there is any question online, and apparently not. I'm only using 4G, but no. Hello, is it possible for the slides of the presentation to be shared with the participants? I guess this is a question for the organizers. Yes, okay, yeah. So all these slides will be shared, no issues. Then I guess it depends on the individual presentations, maybe that some information is a bit sensitive, but no issues, at least for this one. So yeah, this will be shared. Okay, good. So I guess now we can move to the panel. So I will, well, let's say, animate this panel with my colleague from SnT. So we already have a few questions, but maybe before asking these questions, well, I would like to start actually with one question so that everyone maybe can be aware of who you are and what is your relationship, let's say, with the EMF regulations, the EMF exposures. So how much these topics affect your company or your entity? I think this is one question, well, that you can answer, I mean, each of you, so that maybe the audience can better understand who you are. So I would start with you, if this is fine for you as representative of a network operator.
Yeah, for the moment with the current regulation, so for 5G in the 3.6 gigahertz band, we don't use the other available power on, let's say, 60% of our cells. That's one figure. That means that we reduce the power on 2/3 of the network, roughly.
Okay. And so this is only in terms of power, but then how would you estimate the loss in performances? Meaning that if you have less power, I guess the antennas are then less efficient, obviously. Well, maybe
for sure, so a reduction of coverage now with this small traffic we have, we don't have really an impact that can be measured. But of course, a loss of coverage.
Okay, good.
But the question is also how to simulate this, because this power reduction is based really on the simulation of the EMF in the place where people live. And at the moment, we have some questions about how we simulate this. That could be an output of this EMIT project to enhance the way we simulate the EMF.
Indeed, indeed.
Because now we use, of course, the tool we had for 2G, 3G, and 4G that use a static antenna pattern. So it's not really suitable for 5G with the dynamic antenna pattern, with the active antenna.
Okay.
So using this tool that is not, I think, accurate, the outcome with the current regulation has this consequence of reducing the power on, let's say, 60% of the transmitters.
Okay, that's quite a huge number, actually. May I have well, your input, basically, Jamel, maybe,
yes,
for Research Institute?
Great. As a public applied research center, I think that we sit indeed in the middle of two actors. We are not regulators, we are not operators. We are trying to understand where the problems are in a way that we can support and enhance the knowledge. So, of course, here the question is about compliance. So we need to check how the methodologies that are in the market, or those that are in the state of the art, works, especially if we look specifically to this assessment tools that both actors, because if we look into this scenario where the operators wants to deploy and the regulators wanted to check, because they have responsibility of safety measures. Indeed, we sit in the middle of the exercise where there is a room of improvements. Improving because we are playing, of course, a neutral role. We don't have a commercial perspective, pure commercial perspectives, and we really would like to bring this trust between the both actors. I think that there is a room of improvement in both sides because when the technology is there, the operators usually their aim is to maximize the exploitation of this technology. But the regulators would like to minimize the risks, and you have there something to do. And once you understand the activities of this value chain, which is about deploying the antennas physically, but also making sure that things are used afterwards. And you have a trajectory of different things that has to be done there, because you have what we call in our culture the local problem that you have to solve, because you have an antenna to be deployed locally in a physical place. But you have to look at the deployment in a global picture. You need to make sure that, of course, you would like to sustain your deployment. And of course, you might have different strategies. This is a question. But for 5G is more interesting to look at the additional layer, which is the applications, because depending on how many users or which kind of applications you will have to be exploited in reality, I mean the end users, by the way, the technology might be configured differently. And then if you look at these different scales, you have different problems at the different layers. And I think that this is really a good news for an applied center like us.
Indeed. Simeon, what are your views on that?
Yeah, so I share the opinion that, I mean, we are not policy makers, but we still have a responsibility towards two parties. One is the public audience, and the other one is the expert audience. So for the public audience, I think we have to maybe try to speak their language. I mean, it's difficult to explain volts per meter and watts per kilogram, but it might be easier to say that, this percentage of your radiation is coming from 4G and this percentage is coming from 5G right now. So just compare and see if this is more or less. So, or this percentage of radiation you receive from the base station, and this is how much comes from your smartphone. And these are easy to understand comparisons that you can convey to the public audience. Now for the expert, again, we have two, let's say, main parties. One is policymakers from the government. Then we have to work with regulatory aspects. So essentially coming up with the right methodologies to make sure that we are compliant, and we see that there are challenges there. But also for the operators, because there is a big question mark now. The fact that these massive MIMO algorithms are not standardized, it means that it's a competitive advantage for the different vendors. They do not like to share much about it. But in principle, with the measurements that we make, we can try somehow to understand the different flavors of the equipment that you can buy, and whether there are differences in the level of EMF that they generate. So this is what we can do from our side to facilitate, let's say, the network operator side, where this is the main interest, because we don't have any vendor manufacturers in Luxembourg. So for us, the target really in terms of expertise, the operators and the government. So that's all from my side.
Okay, that's quite interesting. So just maybe a follow-up question. I mean, I have the feeling, sometimes as an external, let's say, if I take if I remove my researchers hat, let's say, that all these debates, all these, regulatory factors, let's say, are new. So you are, for instance, citing 60% of the network that is potentially impacted by that. But what was the situation before? How can you characterize the evolution of the network complexity, let's say? What was the situation before 5G? Was it still the same situation 10 years ago, 20 years ago?
We had some power reduction on some side, but it was not this rate. But I think so I don't have the figure in hand in my head for 4G, but I think the point is, the question is the simulation correct? I think that's really the point, because the authorization is made based on the simulation. And I think at that point we use what we have, but we are not sure that it's accurate. Perhaps probably it's overestimated.
Okay, that's clear.
Because the active antenna system is not taken into account. The tool is designed for a static pattern, so the provider of the tool has built a kind of static pattern based on the different patterns for the traffic beams. But is that correct? So we are investigating at the moment with the supplier of the antenna what could be the best approach for that.
Okay. And, well, as a research institute, of which we are part, but anyway, How do you leave this evolution, in the network complexity in these recent years? I mean, in the way you are working, in the models you are producing, and so on. I mean,
yeah, I would like to answer based on maybe the question that was just asked before regarding the way the evaluation, the assessment of EMF is made. Is it generalized everywhere? And it gives an example of the complexity of such an exercise. Indeed, in my point of view, within 5G, it is more complex now to generalize it because the context might be different. You should understand that if you want to evaluate the radiation or the way the antenna is emitting, it's very important to understand that it's dependent from the configuration of the environments. The configuration of the environment is the buildings. We need to have data of the place where the antenna should be built in a way that the simulation and the modeling of the methodologies that will be used there is accurate. Then, of course, if you look at the other place where you would like to deploy it, I mean, you cannot, you use the same methodology because the parameters might be the same, but we cannot use the same profile everywhere, which means that it demonstrates the complexity and of the exercise of the operators, because then if they would like to optimize, optimizing means deploying less and using max. Then it becomes a very complex problem.
Okay. Yeah. If I have
yes, please.
Question.
Yes, hello, thanks. As you know, in 5G, something very new is the time domain duplex. So my question is the following. In a country of Luxembourg, what is undertaken in order to detect a potential interference between countries that Luxembourg can suffer from the use of different frame structures, like it is the case between Germany and France? So what is the approach of Luxembourg to mitigate the problem and at least detect eventually some interference?
Good one. Simon, would you?
Well, I would direct this to, I would say, policymakers and regulators. I mean, we know that there exists a problem, and we are, let's say, researching into it. But to me, this is a very tricky problem in the sense that Luxembourg is rather small. It's caught in between. I don't see any easy solutions, technical solutions, to be honest. But we have been in discussion with the operators, and we know that this is a major problem. That will become even more accentuated when you have more and more base stations being installed, right? And unfortunately, that's the reality of the European Union. We are somehow fragmented. We don't all apply the same policy. And that's why I say that at the end of the day, it might be more of a political problem rather than a technical problem. So I would be open to hear the opinion of the policymakers and operators as well. What's their opinion?
I can maybe just extend the question, because one question which is not about interference, but it's about roaming and interoperability. When you cross the border, there might be some maybe technical interoperability issues depending on the standard that might be used, which is today a challenge. There, of course, the operators are handling this depending on the place where they are, but it might be also a problem. But yeah, the question about the interference, how far is it feasible? I mean, the antennas, the geographical coverage might be less complex than for 4G. Then how difficult is to handle the interference? It's a question mark.
Okay, but the ANFR in France determined that if you have different frame structures, you should have a bandgard of 20 megahertz to avoid the problem, which is quite maybe an extreme position, but the problem is existing. And okay, thanks for your answer for that.
Yeah, I think there are solutions, but they're not efficient solutions. I mean, you waste a lot. You could have done something much better with just better coordination among the...
Yeah, and even within a country, you might have players willing to have another frame structure to cover industrial applications, requiring more uplink, which is adding an additional complexity within the same country, eventually.
I think there was a lot of excitement on the TDD, but it's not all good, as we see right now. I mean, there are problems coming along with it, right?
Okay. Maybe let me drive the discussions toward the radiation topic again. So we're discussing here about 5G radiation nowadays. So in your view, how do you compare the 5G radiation with previous generation, but also what do you foresee for the new deployments and new technical challenge coming in the future in terms of level of radiation? Maybe Thierry from Post.
What do you mean?
I mean, right now we are seeing that there are different technological enablers that we foresee in the future. New bands, new waveforms, TDD. How do you foresee that the level of radiation will evolve? I mean, and what should be the trend? How do you see?
You mean the contribution of 5G to the overall EMF?
Yeah.
We can rely on some measurements that were made in other countries. For instance, in UK, Ofcom has made a huge set of measurements, and it has been proven that the contribution of 5G is quite limited. I don't have the figures in head at the moment, but you can find this kind of report. They are publicly available. And I think in France they have also made a measurement campaign about the contribution of 5G to the global exposure, and that's the same outcome. It's limited, really limited.
Yeah, indeed, all surveys are going in that direction. Yeah.
So there are public figures about the contribution of this technology among the whole set of technology, 2G to 4G, and also the percentage of the ICNIRP level. So you can find it easily, but there is no fear about this. So we don't expect some issues.
Thanks, Thierry. And from the research institution, how do you foresee for the upcoming technologies?
Yeah, you mean beyond 5G or?
Yeah,
I think that the tendency is there. My guess is that, of course, the impact will be less, and the more we are getting into the advanced technologies, the less radiation for me will be challenging. But the only challenging is how to measure, how to make sure that the algorithms, the methodologies are fitting, to make sure that it gives the transparency and the clarity in the way you fulfill the requirements when you deploy your antenna, and how the regulators would check and control that, and how to make sure that the citizens are happy at the end of the day.
Maybe to build on this, I mean, it's hard to project, but I think it should be mentioned that we have very advanced capabilities nowadays to even foresee the new technological advancements. So just to mention that a few years back, it would be inconceivable to be able to run in a research institute a 5G stack, to be able to make measurements. And right now, you can have your own 5G deployment, which is standard compliant. It's software defined. It means that you can probably build a rough version of the standard even before it goes out to the vendors, and you can make experiments and see very early on a rough picture of the impact that they might have. And of course, like 10 years back, this was inconceivable. I mean, you had to wait for the equipment to come out, and even measurement equipment very often was too expensive to afford. So I think we live in exciting times in the sense of the capabilities that we have, and how ahead we can be of the evolutions before we actually wait for them to be deployed. So I think that's something that changed, and that's something that's going to change even further, because now we see that the standards are evolving very quickly, releases with new features every time, and of course the vendors are running behind them to try to produce the features. So it's not a one-off. This is something that we should be doing continuously, and this is a challenge for everyone, obviously, research, industry, and policymakers.
Yeah, indeed. I think that if I may just surf on this, of course we have capabilities in terms of being able to measure, to go for accuracy and bring transparency on the values of what you are assessing. But still there is maybe a gray zone, which is about the technology offerers, telecom, equipment providers. When it comes to 5G, indeed, sometimes it's necessary to look inside and check the way the antenna is working, basically. And of course, today we look at it as a gray box or black box. We measure it from outside, but ideally, if we want to integrate the model of the system, then we will be more generic in terms of assessment than to have an assessment method based on the technology that you have, a specific antenna. If I may say, the evaluation will be dependent on the technology that you have in front of you. And this is why you have this post and Proximus in your case. I understand that you would like to mix technologies in a way that at the end of the day you can bring a knowledge that fits to different technologies. But we do it because you don't have the capability to enter inside. This is gray zone, I foresee.
Yeah. But this is also, I think, a challenge in the simulation aspect, in the sense that even the different software companies that are building simulations, at the end, even them, I don't think they have an exact knowledge on how these algorithms are working. At the end, they're proprietary, right? So even them, they use some kind of mask, some kind of, let's say, upper bounds, which at the end, we don't know how realistic they will be. Right? So that's why I think we need the complementary approaches. You need to do it in the anechoic chamber. You need to do it in the environment. You need to simulate it. Then you might have let's say, an overall approach on what's happening.
Now you're talking about somehow trust or transparency. We see a strong movement against 5G and new technology in general. So how do you think that the authorities or even us, we can increase the trust of the people on new technologies and somehow try to stop this sort of movement against 5G? How do you think we can address this or help on this?
This is a very good question. I think that this is a challenge for the public authorities. But I also believe that tools that all of us should bring into these actors might become important and might push for maybe a change of the way they do their supervision, monitoring, control, whatever we call it. Of course, because in our project, by the way, the 5G emit, we believe that the simulation might be done in a static way. You have a situation of an antenna which is not under exploitation, which is configured to serve a certain needs. But what if? What if the needs are changing? What if the environment is changing? Then, of course, everything should be in a movement, in a dynamic situations. Of course, if we have the procedures, the controlling procedure that has set up there in a way that we do it once, what is the frequency of the control? Because the citizens might be interested to look at where the situation is. What's the timing? Where they reflect the radiation that I have in nearby my living city. So I think that this is very important to include these kind of challenges in the software solutions that we aim to prove at the end of 5G emit at least.
Yeah.
Okay, so maybe I can offer an opinion. So I think it's important to encourage the public audience to ask questions. I get these questions very often. I mean, I talk to friends in social circles. The first question that I get when I mention that I'm doing this job is, about 5G and whether it's safe. But I think most of the times people get their information from some sources that might not be fully reliable. So my approach, and I think the approach of the research community, is just to push them to ask the right questions. You should ask questions, but ask the right questions. To try essentially to move away from conspiracy theories and closer to the real questions that we should be asking. And I think if we try to do this in a more, I would say, approachable manner as a research community, it will help a lot. And at the same time, I think it's both an engineering problem and a biology problem. So we should always remember that yes, we take the limits as given and we work from there. But there are some people that worked to set these limits. So when we challenge some new technology, we shouldn't challenge the science that happened, 20, 30 years back. We should change what's really changed. And this is not obvious to let's say, a big part of the public audience.
Okay, excellent. So we are reaching the end of the workshop. So I would just ask you, maybe each of you, to conclude basically. I mean, how do you see the situation, for instance, in 5 years? I mean, we're already talking about 6G. We know that, the early research on 6G has already started. So how do you see the evolution of all that in 5-10 years' time? Please, Thierry.
We'll always put you up front.
We're facing a short-time problem.
Yeah, indeed.
So I really don't want to answer about what will be in 10 years. But just one comment about your 5G emit. I think it's of big interest for us operator because, as I mentioned, you have some question about simulations, less for measurements, because now we have equipment that got selective measurement. There's still some question mark about the extrapolation factors, but I think we will come next year to a clear solution. But regarding simulation, we still have some question on how to do it.
Let's collaborate, I would say.
Sorry?
Let's collaborate, I guess. Jamel?
Yeah. Future, I think that we can scale it over the different momentum. I think that for the short term, we believe that bringing simulation is the key. We are all here are doing computational science, which you have models, simulations, and the experimentation at the same time. We mix all together in a way that you can bring this simulation working for the situation that we have today. But quickly, once this is solved, we will face the problem of how to adapt the applications. I think that this is extremely important because everyone will be trusting the technology. The operators would deploy the solution, and we will be looking for application. And then I think there is another stage where I believe there will be plenty of activities where we have to evaluate or optimize the network capabilities regarding the applications. And maybe the third stage, which is more in the future, because once we have this 5G, I think that there are plenty of new paradigms coming that goes into the direction of edge computing, of different other principles that will really change the way our society or our digital systems will work. This is, for me, a very good news for us, that researchers to bring in this vision, which allow us to go more in the perspective of new technologies and new society.
Yeah, just to mention that, I think the questions that we're posing here will persist for many years. I mean, already in 6G, we see that there are concepts of reflective intelligent surfaces, which means that you're trying to affect the electromagnetic environment even within a room by just putting some passive elements, in the walls. So that, that goes along the direction of beamforming, but in an even more intelligent manner, which make it even more challenging on how to regulate at every point in the room that you are compliant to the levels. Spectrum speaking, there are already studies about terahertz. So, even higher frequencies, people will be even more skeptical that, the higher you go, the more, the higher the danger is from radiation. So I think these questions will persist for a few years, even in 6G. So we have to find some convincing ways of answering, both for the experts and the non-experts. So I think that's a challenge in the years to come.
Okay, on these words, well, thank you very much for your participation. Thank you very much, everyone. So this is the end of this workshop. Then, well, I guess we need to leave the room quite quickly, right? Because the next workshop is in 5 minutes. So thank you.